Okay, so we're going to review AP. We're going to do an AP review for Unit 2, which was regression. We did a lot of this last week. That's why we're starting with Unit 2 instead of Unit 1. I just want to cover a few other topics from Unit 2 that we didn't talk about last time. So we talked about the computer output. Remember, the top value is the y-intercept. Under that is the slope. This is the x variable. We use these numbers over here for inference, which we won't be doing on the AP test this year, 2020, but we will be doing next year, 2021. We're not going to use the r-squared adjusted. We use this r-squared value to calculate r, convert r-squared to a decimal first, and then square root. Remember, r-squared is always positive, but r can be positive or negative. R needs to match the sign of the slope. So whatever sign the slope is, that's going to be the sign for r. And then we have the x variable there. So you write your equation like that. Y hat equals 107.58 plus 0.8710x. And then you need to write out what x and y are in words like this. Okay, we have all of our interpretations. The slope interpretation is a pretty common thing on the AP test, so make sure you know that one. Remember, slope is change in y over change in x. So I'll usually write the slope as a fraction first, the number over 1. And then I know that's change in y over change in x, so I'll put the units with it. And that helps me remember the general pattern so that I don't make a mistake. Also, make sure you include the word predicted or something else that's a modifier like that. You could also use on average, but something that indicates that that amount is not exact. Same thing with the y-intercept. When the x variable is equal to 0, the predicted y variable, make sure you say predicted or average. Correlation coefficient, there's a, for your strength, it's either strong, moderate, or weak. Remember, our general guidelines, we use strong is between 0.8 and 1, moderate is between 0.5 and 0.8, and weak is between 0 and 0.5. So make sure you're keeping those in mind, but remember those are guidelines. So you might see different numbers somewhere else. If you're looking at a graph trying to determine if it's strong, moderate, or weak, and you can't decide between strong and moderate, call it moderately strong. If you can't decide between moderate and weak, call it moderately weak. But only do that when looking at the graph. If you have R, you should be able to determine which it is. And then direction is going to be positive or negative, linear relationship between x and y. Coefficient of determination, r squared, percent of the variation in the y variable could be explained by the approximate linear relationship between the x and y variable. For your residual, remember the residual is y minus y hat. The actual y variable is however many y units above if the residual is positive, below if the residual is negative, the predicted y variable. I don't really memorize this part. Instead, I just look at my actual y and my predicted y, and I see if I'm above, if my actual is above or below the predicted. So instead of memorizing that, I just look at the actual numbers when I'm interpreting the residual. If you want to see examples of this, watch the video, the first part of the video from last week where I go through those examples in the notes. Some fun facts about regression that might or might not be useful. A random residual plot shows the model being used is appropriate. So if you're looking at a residual plot, it's good if the residual plot is random. That means that model is correct or is appropriate. A residual plot with a pattern shows that a different model would be a better fit for the data. Remember, correlation does not imply causation. The only way to show causation is with a well-designed, well-controlled experiment. So you can talk about a relationship between x and y, but you shouldn't say that x causes y to change unless you did an experiment, because there could be a lurking variable or a confounding variable somewhere in the problem or in the situation. Don't forget to define your x and y variable when you write your equation. An outlier in a regression setting is a point with a large residual. So it's going to be a point that's far away from the LSRL. An influential point is a point that significantly impacts the LSRL When removed, the LSRL significantly changes. This point can be close to or far from the LSRL. An outlier is usually a influential point, but it might not be. You would check it by removing it. But a point that's really close to the line but is really far away from the other points is also often an influential point. That's actually usually what we think of if we reference an influential point, is a point that's close to the line but is actually really far from the rest of the data. Typically on the AP exam, they don't have you calculate the LSRL with the calculator, but I just want to practice doing it just in case they do put it on the AP test. So we're going to look at this example. Okay, so here you should be able to see my calculator screen and the PowerPoint. So here we're given the age and months and the height in inches of 7 children. We want to find an LSRL and the correlation coefficient, draw a scatter plot, and draw a residual plot. So the first thing you want to do is, if I'm going to find the correlation coefficient on the calculator, I have to turn my stat diagnostic on. To do that, you go to Mode, and then go to Stat Diagnostics down here, and turn it on. If you have an older calculator, you might need to go to Second Catalog. I need to go to just Diagnostic. So hit the D, which is on the X to the -1, and I want Diagnostic on, and then I press Enter. So that's the old school way to do it. If you have an older calculator, you might need to, but most of you should be using a TI-84 or higher. My next step is to type these numbers into my list. So 16, 24, 42, 60, 75, 102, 120, 24, 30, 35, 40, 48, 56, 60. So you have those numbers typed into your calculator. First, it says find the LSRL and the correlation coefficient. To find that, you go to Stat, Calc, Linear Regression. Notice linear regression is number 4 and number 8. In algebra, you always did number 4. In statistics, they typically set it up like number 8. Doesn't matter which one you pick, as long as you write your equation correctly with the slope being with x. I'm going to pick number 8 since we are statisticians right now. So I want my x list to be L1, my y list to be L2. Calculate. So when I write my equation, all right, y hat equals A, so 20.4036. And then I did A plus BX, so plus B 0.3421 x, where x equals the age in months and y equals the height in inches. That's how you write the equation. It says draw a scatter plot. If you're asked to make a scatter plot on the AP exam, you need to individually set up your x and y axis, plot the x and y coordinates. It's not just a sketch they're looking for. They're looking for a proper scatter plot. So on the calculator, if you need to look at the scatter plot, go to second y equals or second stat plot, turn the first stat plot on, select the scatter plot, and then hit zoom 9. So that's about what it should look like. We can see that's a strong positive linear relationship. Oh, I didn't write down R when I did my linear regression. but it was given to me right there, r equals 0.9941. And it says sketch a residual plot. If you need to look at the residual plot on your calculator, which I don't think you will on the AP test, I'm showing you just in case. First, you have to do linear regression, which I just did. So after you do linear regression, you go to second y equals, select your first scatter plot, turn it on, change the y list to the residual list. To do that, you go to second list, and residuals will be at the bottom only if you did linear regression first. So you have to do linear regression. That's how, when they do linear regression, they calculate the residuals. So now I hit zoom 9 again, and that's my residual plot. And that residual plot is definitely random, so a linear model is appropriate in this case. For the next one, so I've never seen an AP exam where you actually use these formulas, but just in case I wanted to talk about them, this is the first part of your formula chart that you will be getting. Somehow you'll be able to access it when you do it on the computer. I don't know. Typically you're given one of these like on a paper copy in your booklet. But in 2020, you'll have it online somehow. I don't know. So these big ugly formulas we are not going to use. This is actually the formula for mean. That's the formula for standard deviation, but you should not ever need to use this for this course at least. And then this is the formula for R, but we don't use that formula. We either get R from the computer output by taking the square root of R squared as a decimal, then checking to see if it's positive or negative, or we get it directly from the calculator, or it's given in the question. Instead, we're going to use these three formulas. So this one. For this one, it says y bar. Remember, y bar is the average of y, equals a plus b times x bar. We're actually going to use this in the format a equals y bar minus b times x bar so that we can get a. But before we get a, we need to get b. So you'll have to do this one first. And then this one second. And then remember, R is your correlation coefficient, S is the standard deviation of either Y or X. B, when it's written this way, is your slope, and A, when it's written this way, is your y-intercept. So the following statistics are found for the variables of posted speed limits and the average number of accidents. Find the LSRL and predict the number of accidents for a posted speed limit of 50 miles per hour. So remember, we start with B. So we're going to do R times S of Y over S of X. So B is going to equal R times S of Y over S of X. And then after we get that number, we find A. So A equals, so remember on the formula chart, it says Y equals A plus B times X bar. I can easily manipulate that by subtracting Y bar minus B times X bar. So Y bar is the average of Y minus B, so whatever that number is will go down here, times X bar, which is 40. So you should type this in your calculator. I trust that you can do that, but I want you to do it right now just to make sure you know what you're doing. And you should get 0.7228 for B, your slope, and negative 10.9105 for A, your y-intercept. For whatever reason, I wrote this in BX plus A instead of A plus BX, but that's okay as long as the slope is in front of X. So you also could have written it y hat equals negative 10.9105 plus 0.7228x. I don't care which way you write it, and neither does College Board. Statisticians write it this way. In algebra, you wrote it this way. But we're all mathematicians, and we know that both ways are exactly the same. And then to predict the number of accidents for a posted speed limit of 50, you're going to plug 50 in for X to see what you get. And you should get that number. Even though we can't have a partial accident, we leave it as a decimal because when you make a prediction, you're really saying on average, this is what I expect. So hopefully this was a good review of regression. Still good to look over your notes and make sure you understand what we've done in the past, but these are the main topics from that unit.